Hi students, today we are going to discuss our very first unit, wave optics, in our engineering physics, and let us see what is the wave optics. Optics. Wave optics means which deals with the light, and these three are the important concepts which we are going to study in this unit. Those are interference, diffraction, polarization. Let us start with the introduction of light. Light has dual nature, that is particle and wave nature. That means a wave, let us consider a wave, that is the light wave. There is nothing but an electromagnetic wave that consists of both particle nature and wave nature. Wave nature of light, that is proved by interference and diffraction phenomena, which we are going to study in the next chapters. In general, we have two types of waves. One is the longitudinal wave and the other is the transverse wave. Longitudinal wave means the displacement of particles, that is along with the direction of the wave, that is parallel to the direction of the wave. And transverse waves means the displacement of particles that is perpendicular to the propagation of wave in a medium. Now polarization. Polarization means that proves the light has transverse wave nature. Okay, interference phenomena, that is proved by this, and the polarization proves that light has transverse wave nature. So now we are talking about the optics. There are two types, physical optics and geometric optics. What is the difference between these two means? Physical optics or wave optics, that is the branch of optics that studies with the interference, diffraction, polarization, and the other phenomena for which the ray approximation of geometric optics is not valid. So for the ray approximation, geometric optics, that is not valid. So that's why we have to prove the interference, diffraction and polarization phenomena through the wave optics only. So let us see what is the interference. But before going to the main topic interference, let us recall some basic definitions. What are those means? Like reflection, refraction, transmission, and optical path, wavelength, amplitude, frequency, like that. Some basic definitions we are going to discuss. Let us start with the reflection. When a ray of light approaches a smooth polished surface and the light ray bounces back, it is called the reflection of light. See here in this diagram, it is very clearly shows that the phenomena of reflection. One is the incident ray and the other is the reflected ray, and the normal which we are drawn. Here we are observing that the angle of incidence is equals to the angle of reflection. Okay, and next, refraction. Refraction means the refraction is the bending of a wave when it enters a medium where its speed is different. So the propagation of light is different from one medium to another medium. So whenever the light entering from one medium to another medium, the speed of the light, that is different. So the refraction of light, when it passes from fast medium to a slow medium, it bends the light ray towards the normal, to the boundary between the two media. So the bending occurs towards the normal. Let us see. There is a incident ray and also a normal. The bending occurs towards the normal. See, angle of incidence, or that is the angle of refraction. And next, optical path. What is meant by optical path? The path that light takes in traveling an optical medium or a system, that is often called the optical path. The light the path of the light which through it travels, that is said to be a optical path. See here, AB, that is a normal, and we have a incident ray, and the bending occurs towards the normal here also. This diagram just shows the path of the light which it takes to travel. Simply, this is an optical path. And next, wavelength. Wavelength, amplitude, frequency, all those are very basic definitions. Let us see or just recall the old definitions, very basic definitions. Wavelength. That is the distance between the two identical points. They may be between two adjacent crests, that means two successive crests or two successive troughs. In this adjacent cycles of a waveform, signal propagated in space. So, from one crest to another crest, the signal that is propagated in space. And the wavelength means the distance between the two successive crests or troughs, that means the identical points between two successive crests or troughs. The diagram that illustrates very good definition of wavelength. And next, let us see frequency. The number of waves that pass a fixed point in unit time. Also, the number of cycles or vibrations undergo during 1 unit of time by a body in periodic motion. Whenever we are taking a regular interval, that means frequency. When we are considering the wave, the number of waves passing through a point in a unit time, that is said to be a frequency. According to the oscillations, the number of oscillations per unit time, that is also a frequency. And according to cyclic process, the number of cycles that a vibrating body vibrates in a unit time, that is also a frequency. Okay, but here we are discussing about waves. So the number of waves that passes through a point, a fixed point in a unit time, that is said to be frequency here. Next, amplitude. Amplitude. What is meant by amplitude? The maximum displacement or a distance moved by a point on a vibrating body or a wave. So here we are considering a wave, and from the equilibrium position, how much extent, the maximum displacement that a wave can reach. So that we are measuring here, that is the amplitude. Okay, and next, phase difference. What is meant by phase difference? The phase difference is the difference in the phase angle of two waves. See here, we are having two different waves with the different phase angles. So, from one wave to another wave, how much the phase will varies, that is the phase difference. And now, path difference. What is meant by path difference? Let us consider a source and a destination. There are so many paths to reach from source to destination, but path difference is the total path. This is the difference in the path traversed by the wave. See here how much the path 1 will be and the path 2 will be. Path 1, that's the indirect. It's the indirect path to the destination. And the path 2, that's the direct path from source to destination. That means a light ray, a wave that can travel from a source to destination, which type of path that it will take, that is said to be a path difference. And next, coherence. Coherence means generally which has the same frequency, that means same wavelength, amplitude with a constant difference, then that source is said to be a coherent wave. Let us see, two wave sources are perfectly coherent when we will say that it is a coherent source, if their frequency and waveform are identical and their phase difference is constant, then the sources is said to be coherent sources. See in this diagram, the both waves have the same frequency and wavelength, but with the constant phase difference. The difference between the two waves, that is a constant. Okay, and let us see what are the types of coherence. What is the basic types of coherence? How we can differentiate these two means. One is the temporal coherence and the other is the spatial coherence. Temporal coherence means if it is possible to predict the phase relation at a point on a wave with respect to the another point on a same wave. The coherence we are saying according to a single wave. Within the wave, phase relation between 2 points, then the wave is said to be a temporal coherence. And in a spatial coherence, it is said to, in that spatial coherence, we are taking two waves. If it is possible to predict the phase relation at a point on a wave with respect to another point on the second wave, in the temporal coherence, we are considering two different points at a single wave. And in spatial coherence, we are taking the points in different waves. That means two different waves. So both are having constant phase difference. Then the wave is said to be a spatial coherence. Okay. And next, this is the main difference. In the temporal coherence, we are considering two different points in the same wave, and the spatial coherence, and in the spatial coherence we are considering two different points in a two different waves. And let us see, it's a monochromatic source, a light source emitting one color of light. This is a single color, single wavelength. Okay. And now, what is the basic principle of interference? Principle of superposition of waves that causes the interference. When two or more waves travel simultaneously in a medium, the resultant displacement at any point, that is due to the algebraic sum of the individual waves. Okay. For this interference, we are considering two waves. That means two or more waves travel simultaneously in a medium. Then we have the resultant wave. That is, the displacement at any point is due to the algebraic sum of the individual waves. So this is the principle of superposition of waves. So when the interference occurs means superposition of two or more waves within a medium. So this is the principle of superposition of waves. Now we are taking two waves, individual displacement waves, that's a y1 and y2. Let us see what is the resultant wave. What is the resultant displacement of the wave is y equals to y1 plus or minus y2. Why we are having here the plus or minus means in the interference we are having two types. That's the constructive interference and the destructive interference. We will talk about that later. Let us see. When the displacement changes, amplitude changes, then intensity changes. Okay. See very carefully. When displacement changes, amplitude changes, then intensity also changes. So the modification in the distribution of intensity in the region of superposition, that is known as a interference. Okay. Single slit, when the source is passing through a single slit, after that it also passes through the double slit. See what happens here, how the interference pattern will occur. Simply the modification in the distribution of intensity in the region of superposition, that is known as the interference phenomenon. Now, as earlier we said, there are two types in interference, that is the constructive interference and destructive interference. Let us see what is the constructive interference. If the resultant amplitude is the sum of the amplitudes of two waves, then the interference is constructive interference. So, here we are representing a wave in a green color and in a blue color. Those two are the two waves. Initially we are taking two waves, and the other wave which we are presenting, that is the resultant wave, means sum of the individual waves, sum of the amplitudes of the two waves gives the interference pattern, that is the constructive interference. Next, destructive interference. If the resultant amplitude is the difference of the amplitudes of two waves, see here, what is the you just observe what is the difference between the constructive and destructive interference. Constructive means sum of the amplitudes, destructive means difference in the amplitudes. That also gives the destructive interference pattern, and that is said to be a destructive interference. Now, the intensity variations are studied as interference patterns or bright and dark fringes. So, according to the intensity variations, we are studying those as interference patterns or bright and dark fringes. Okay, and just see, as earlier we said, the interference pattern occurs by the superposition of two or more waves. So for that interference, what are the basic conditions we have? Let us see. The two light sources emitting the light waves should be coherent. We already know the conditions for coherent, and now the two light sources emitting the waves should be coherent, and means the sources which we are taking for the interference conditions, those should be a coherent sources, and the separation between the two sources should be small sources. So the two sources separation, that should be small, and the distance between two sources and the screen should be large. Distance between two sources should be small, and the distance according to the screen, that should be large. Okay, and now background should be dark, as we already know, and the source should be narrow and monochromatic. So for this also we have a diagram in the previous slides. That means a monochromatic source. I already said that monochromatic means which has the single color, that means single wavelength. So simply this is about the interference and principle of superposition, and what are the basic conditions for the interference. Let us see general example for interference. Okay, this is the general example for the interference as we regularly see in our daily life.